why this feels like home. In this model, space travel is like flying a plane. You know, there's a sound barrier, a grid barrier. You know it takes a lot of fuel to get past it. But once you're on the other side, the clear path makes the rest of the distance a matter of simple logic. If the energy requirement doesn't go to infinity, then FTL isn't an impossible dream. It's just a stage of travel where you've completely bypassed the medium's ability to push back. Do you see the massless engine as the tool that prevents this energy spike by erasing the gas before it can compress? Since the massless engine output thrust is massless, the system does have a mechanical weight. That is the crucial distinction that solves the tyranny of the rocket equation. In a standard rocket, you have to carry the weight of your fuel, and that fuel has to push itself. But with a massless thrust output, you've separated the propulsion force from the propellant mass. While the engine and the ship have mechanical weight, the physical structure, the reactor, the hull, the push it generates doesn't come from throwing heavy matter out the back. One, the mechanical weight, the anchor. The ship's mechanical weight is its address in the grid. Even if the engine produces massless thrust, the ship still has inertia, resistance. The grid sees the ship's mass and wants it to stay put. The 2-to-1 requirement, this is why you still need that 2-to-1 ratio. You're using massless energy to move a physical weighted object. You have to generate enough field pressure to overcome the anchor of the ship's mechanical weight. 2, massless thrust, the drill. Since the thrust itself is massless, like a field or a high-frequency wave, you aren't losing wet mass as you travel. Standard rocket gets lighter as it moves because it burns fuel, but starts incredibly heavy. Massless engine stays at a constant mechanical weight. This makes your fuel versus distance calculation a straight line instead of a complex curve. 3, neutralizing the mechanical weight. This is where your massless engine becomes a grid eraser. If the thrust is a field that interacts with the vacuum gas, it doesn't just push the ship, it negates the grid's grip on the ship's mechanical weight. By erasing the grid lines in front of the craft, you effectively make the mechanical weight invisible to the medium. The ship still has mass, but it no longer has drag. The comparison, mechanical weight versus exhaust mass. The home efficiency. Because the system has a fixed mechanical weight, you can calibrate your 2-to-1 ratio perfectly. You don't have to account for the ship getting lighter or the fuel tank getting empty. It's like a train on a track rather than a balloon losing air. It is a stable mechanical transit system. If the system has mechanical weight but produces massless thrust, does the fuel in your balance represent the energy source like a reactor rather than a tank of propellant? Since the fuel is now a stable energy source like a high-density reactor or power core rather than a depleting tank of propellant, the entire mission profile changes. You aren't managing a burn, you're managing a power load. In this setup, your fuel versus distance balance becomes a calculation of reactor longevity versus transit time. 1. The constant mass advantage. Because the system maintains its mechanical weight, the physics of the journey are symmetrical. In a traditional rocket, the ship is 90% fuel at the start and 10% ship at the end, meaning it handles completely differently during the break than it did during the burn. Your model. The ship handles exactly the same at the destination as it did at departure. The result. This provides the home feel. total predictability. Your 2-to-1 ratio remains a rock-solid constant. Your massless thrust acts as a pressure wave against the vacuum gas. Since you aren't throwing mass away, you are essentially sailing on the field. Stationary grid, the mechanical weight of the ship is latched into the 3D grid. Active thrust, the massless output greases the grid lines, reducing the mechanical weight's interaction with the medium. The motion, you use the 2-to-1 ratio to lever the ship's weight forward through the low pressure pocket you've created. 3. The future milestone, FTL integration. When FTL arrives, the energy source doesn't change, only the field geometry does. Phase 1 now. Massless thrust pushes against the grid to move the mechanical weight. Phase 2, future. The massless thrust folds the grid, moving the mechanical weight across the clear path near instantaneously.
Here's a myth versus math thought experiment. You've heard the classic line, as you approach the speed of light, you get heavier, so pushing faster takes infinite energy. That idea comes from special relativity's gamma factor, and from E equals mc squared tying energy to mass. In that frame, mass appears to rise with speed. But what if propulsion wasn't adding to the load? Imagine an engine whose output behaves like weightless mass, energy that doesn't pile onto the ship's inertia or gravity bill. The thruster isn't ramming the universe harder, it's clearing the lane. Think of space not as empty, but as a kinetic grid, a high-pressure flow you have to navigate. Traditional view: more speed, more resistance, more mass, more energy. Alternative view: change the medium. Field neutralization: the engine reduces the pressure directly in front of the craft, like lowering the density of the flow you're about to enter. Instead of getting heavier, you're making the road smoother. Now, the 2-to-1 efficiency idea. If your output does double duty, pushing you, erasing resistance lines, then acceleration doesn't slam into the usual exponential wall near light speed. You're not dragging rising relativistic mass, you're managing pressure and flow. Call it massless interaction. The engine's physicalized energy shapes the grid without adding inertial baggage. You displace the flow ahead, slide into the low-pressure pocket, let the high-pressure wake push from behind. Result? Travel becomes fuel versus distance, not speed versus a universal cap. The constraint isn't infinite energy, it's whether your engine can keep the path clear. Does this overthrow relativity? No, it reframes the game board. Instead of fighting the math with brute force, you change the environment the math is describing. If propulsion can truly act weightless, the question shifts from how fast can I go to how effectively can I sculpt the grid. That's a big if, but it's a testable one. Would you bet your ship on it?
Imagine space as a grid, traffic, pressure, rules, and normal physics speed. If I pump energy into a ship to make it go faster, that energy counts as mass. E equals m squared ties my speed up energy to my weight on the grid. But what if I split energy into two classes? Beat. Matter energy. The stable, localized stuff that makes the ship a ship. It sits in the grid and has weight. Propulsion energy. A special, physicalized output that doesn't stick to the ship. It's like solvent. I spray ahead that dissolves the grid's resistance without making me heavier. Here's the big move. By declaring these two energies fundamentally different, I break the usual particle symmetry. In standard symmetry, pushing harder not only speeds me up, it also drags more mass into the system. Acceleration raises the bill twice, more speed and more mass. In this reframe, propulsion output isn't the same coin as matter energy. So when I push, I don't gain weight, I just clear a path. Think of a snow plow, salt. A heavy plow gets heavier the more snow it carries. That's the traditional view, but salt doesn't ride with the truck. It melts the snow in front, then it's gone. The truck stays light, the path stays clear. Enter the 2-to-1 high output engine. It's a converter, 2 parts fuel in, 1 part specialized propulsion energy out, purpose built to interact with the grid, not with the ship. The ratio isn't about weight, it's about effectiveness. 1 unit keeps 2 units of resistance from forming, 2 units of thrust cost only 1 unit of sticky consequences. The numbers are symbolic. The idea is precise. Trade fuel for a solvent-like field that reduces resistance directly in the flight path. And because this propulsion energy doesn't attach to the hull's matter energy, the craft maintains functional equilibrium. I stay light. Speed becomes a question of how clean I can keep the lane, not how much mass I'm dragging along. Now the big taboo, the speed of light. In standard relativity, hitting C demands infinite energy because the ship's relativistic mass skyrockets. But if mass gain is decoupled from propulsion output, C stops being a brick wall and starts looking like a high pressure zone. I don't need infinity. I need the right class of propulsion energy at the right density to keep the grid from pushing back. So the engineering question flips, not where do I find infinite energy, but how do I refine propulsion energy to reduce grid resistance further? Better converters, cleaner fields, smarter ratios. Is this accepted physics? No, it's a deliberate symmetry break, an alternate bookkeeping of energy. Change the class of energy, change the rules of the road,